Welcome to the Power Book of Podcasts. Unlock your potential with powerful book summaries that inspire personal growth and broaden your understanding of the world. Each week, we explore life-changing ideas, from leadership to mindset strategies to keys for happiness and success. Learn actionable insights to apply in your daily life. Join our growing community of thinkers and seekers. Like, comment, and hit that subscribe button now. It's time to supercharge your mind with the Power Book of Podcasts.
Welcome to the Deep Dive. Today we're diving deep into parallel universes.
Oh, exciting.
Yeah, a topic that's both fascinating and a bit mind-bending.
Definitely.
We've got some intriguing excerpts from Brian Greene's book, The Hidden Reality, to discuss.
Yeah.
He explores various theories suggesting that our universe might not be the only one.
Right.
That there could be countless others out there, perhaps even with infinite versions of you and me.
That's the idea, yeah.
Okay, so...
The idea of parallel universes, once relegated to science fiction, has become a subject of serious scientific inquiry. And Greene's book lays out some of the leading theories in physics that support this idea.
Yeah.
And we're here to kind of guide you through this complex and exciting landscape.
Okay, let's jump right in. Greene starts with the concept of infinite space.
Okay.
Which immediately makes me think, if space is infinite, wouldn't everything have to repeat eventually? It's like that thought experiment where you have an infinite number of monkeys typing on an infinite number of typewriters.
Right.
Given enough time, one of them would have to type out the complete works of Shakespeare.
Yeah, that's a great analogy.
Right.
And it actually applies quite well to the idea of cosmic repetition.
Okay.
Greene uses the example of a fly buzzing around in an infinitely large room.
Okay.
On the one hand, the fly has an infinite number of possible positions and speeds.
Right.
But quantum mechanics throws a bit of a wrench in things because it tells us there's a limit to how accurately we can measure those positions and speeds.
Okay.
So the fly's possible experiences, even in an infinite room, are actually finite.
So even with infinite space, there are only so many ways you can arrange things within a certain area.
Exactly. Now let's apply that to the universe.
Okay.
Even with an immense amount of energy and particles spread across vast distances, the possible arrangements within a cosmic horizon, which is basically the limit of what we can observe, are finite.
So we've got these cosmic horizons, each with a finite number of ways to arrange things inside them. I'm starting to see where this is going.
Yeah, so if the universe is truly infinite, then those finite particle arrangements within each cosmic horizon would have to repeat. Somewhere out there in the vast expanse of space, there should be another cosmic horizon identical to ours, with another Earth, another solar system, and another you experiencing this very moment.
That's wild. So just by the laws of probability, if you have infinite space, eventually things have to start repeating. It's like having a finite set of Lego bricks.
Okay.
If you have an infinite amount of space to build, eventually you'll end up building the same structures over and over again.
Precisely. That's one of the simplest yet most mind-boggling ways to imagine parallel universes.
Yeah.
But there are other theories out there that get even more complex and fascinating, like the idea of inflationary cosmology.
I remember reading about that in Greene's book. It was proposed to solve some issues with the Big Bang Theory, right?
Exactly. One of the biggest problems with the Big Bang Theory is what's known as the horizon problem. Okay.
The theory couldn't explain why distant parts of the universe, which have never been in contact with each other, have the same temperature.
That is weird when you think about it. It's like finding 2 cups of coffee billions of light years apart that are at the exact same temperature, even though they've never been near each other.
Yeah, how could they possibly have reached the same temperature if they've never interacted?
Yeah.
That's the puzzle.
Yeah.
And the theory of inflation offers a potential solution.
Okay.
Inflation proposes that in the first fraction of a second after the Big Bang, the universe went through a period of incredibly rapid expansion, much faster than the speed of light.
Wow.
This rapid expansion would have smoothed out any initial temperature differences and brought those distant regions into contact with each other very early on.
So it's like those 2 cups of coffee were once in the same pot before being poured into separate cups and flung to opposite ends of the universe.
Yeah.
I'm starting to get it. But I thought the speed of light was the cosmic speed limit.
How could the universe expand faster than that?
That's a common misconception. The speed of light is the speed limit for objects traveling through space.
Okay.
But the expansion of space itself isn't bound by that limit. Think of it like dots on a balloon. As you inflate the balloon, the dots move farther apart, not because they're moving across the surface of the balloon, but because the balloon itself is expanding.
That's a great visual. So inflation solves the horizon problem.
Yes.
But how does this connect to the idea of parallel universes?
The idea is that this inflationary process may not have been a one-time event.
Okay.
What if inflation is happening continuously?
Okay.
Creating countless bubble universes with different properties as it goes.
So instead of one Big Bang, we have multiple Big Bangs happening all the time.
Right.
Creating these bubble universes that inflate and expand away from each other. That sounds a bit like a cosmic bubble bath.
You could say that. Each of these bubble universes could have its own unique laws of physics, its own set of fundamental constants, and its own cosmic history.
Okay. That's pretty wild to imagine.
Yeah.
So we've got infinite repeating universes.
Yes.
And then we have this inflationary multiverse with countless bubble universes popping up all the time. Is that everything?
Not even close. Brian Greene explores other fascinating theories, like string theory, which introduces us to a concept called brain worlds.
Oh, yeah, string theory. That's the one where everything in the universe is made up of tiny, vibrating strings, right?
Right.
And those vibrations determine what kind of particle something is, like a tiny cosmic orchestra playing different notes to create all the matter and energy we see around us.
That's a pretty good way to put it.
Yeah.
But string theory also requires the existence of extra spatial dimensions beyond the three we experience.
Extra dimensions. You mean like up, down, left, right, forward, backward, but then what? Inside out? Sideways?
It's hard to visualize.
Yeah.
But imagine those extra dimensions are curled up incredibly small. Billions of times smaller than an atom. That's why we don't perceive them directly.
So they're like tiny hidden dimensions tucked away within the fabric of reality.
Yeah.
Okay, I'm trying to wrap my head around that.
Yeah.
So how do brain worlds fit into all of this?
Well, imagine that our entire universe is a three-dimensional brain.
Okay.
Like a giant sheet or membrane floating within a higher dimensional space.
Okay.
And what if there are other brains out there, too?
Right.
Hosting their own separate universes.
Oh, hold on, let me get this straight. So we're all living on this giant flat sheet.
Yeah.
And just a tiny distance away, in some higher dimension we can't even perceive.
Right.
There's another sheet, another brain with a whole other universe happening on it.
Yeah.
Like a cosmic apartment building with universes stacked on top of each other.
That's a good analogy. And some physicists think these brains can even interact with each other.
Interact. Okay.
Gravity, for example, might be able to leak between brains.
So we wouldn't necessarily see these other universes, but we might feel their gravitational pull, like a cosmic neighbor knocking on the wall. That's fascinating.
It is. And it shows how the concept of a multiverse can emerge from different areas of physics.
Right.
It's not just a philosophical idea.
Yeah.
It's something that emerges from our attempts to understand the fundamental nature of reality.
Okay, we've covered a lot of ground already. Infinite repeating universes, inflationary bubbles, brain worlds. My brain is buzzing with all these possibilities.
It's a lot to take in.
Yeah. But Greene doesn't stop there, does he? There's more to explore in his book, right?
Oh, absolutely. We still have to delve into the string landscape,
Okay.
a concept that arises from the mind-boggling number of possible configurations for those extra dimensions in string theory.
Right.
But I think that's a good place to pause for now.
Agreed. We've given our listener a lot to think about already.
Yeah, let's let these ideas settle in before we jump into the even stranger concepts that await us.
Sounds
Okay. Welcome back. Before the break, we were just starting to touch on the idea of the string landscape.
right, the string landscape. I remember this being one of the most mind-boggling parts of Greene's book. It emerges from string theory, right?
Yes. You see, string theory suggests there could be a colossal number of different configurations for those extra dimensions we talked about.
Okay.
Each configuration would lead to a universe with its own distinct set of physical laws and constants.
So each configuration is like a blueprint for a universe.
Yeah.
And there are potentially billions upon billions of these blueprints out there.
That's right.
Each one resulting in a universe with different properties.
Yeah. To give you an idea of the scale,
Okay.
some physicists estimate there could be as many as 10 to the power of 500 different possible configurations.
Wow. That's a 1 followed by 500 zeros.
Exactly.
That's an almost incomprehensible number of universes. But wouldn't most of them be pretty inhospitable?
That's possible.
Like maybe gravity's so strong that everything collapses into a black hole.
Right.
Or the electromagnetic force is so weak that atoms can't even form.
That's a very perceptive question. And that brings us to the fine-tuning problem.
Okay.
This problem highlights the fact that the constants of nature in our universe seem incredibly finely tuned for life to exist.
Right. It seems like an incredible coincidence that all these constants in our universe just happen to be perfectly balanced for stars to form, planets to coalesce, and life to evolve.
Was it just dumb luck?
Yeah.
Or is there something more at play?
That's the debate that has puzzled physicists and philosophers for decades. And the multiverse idea offers a potential solution.
Okay.
If there truly are countless universes with every imaginable combination of physical constants, as the string landscape suggests, then it's not so surprising that we find ourselves in a universe that supports life.
So we just happen to be in the universe that won the cosmic lottery. The one with the right combination of ingredients for life to emerge.
You could say that.
Okay.
Think of it this way. If you have enough lottery tickets, someone is bound to win eventually. Right, even if the odds are astronomically against it. The multiverse might be like a cosmic lottery, where every possible combination of physical laws and constants is being played out somewhere.
That's an interesting way to think about it. But it still raises questions about the nature of scientific explanation.
Okay.
If every possible outcome exists somewhere, does that mean there's no point in trying to understand why our universe is the way it is?
That's a valid concern. Some physicists do worry that the multiverse concept might lead to a sort of scientific nihilism.
Right. If everything that's logically possible exists in somewhere, what's the point of searching for underlying explanations?
Exactly. It's like saying, why bother trying to understand why water boils at 100 degrees Celsius?
Right.
There's probably a universe out there where it boils at 50 degrees.
Yeah. But many physicists argue that even within a vast multiverse, there could still be underlying principles that govern the distribution of different universes.
Right.
It's like studying the diversity of life on Earth.
We see an incredible variety of species, but there are still underlying principles of evolution and genetics that explain why certain traits are more common than others.
Yeah, so there could be a sort of metaphysics of the multiverse that explains why certain types of universes are more likely to exist than others.
Yeah.
Even if the range of possibilities is truly vast.
That's one way to think about it.
Yeah.
The multiverse doesn't necessarily invalidate the search for deeper explanations.
Right.
It just expands the scope of what we're trying to explain.
Exactly.
Okay, that makes sense.
Yeah.
It's like saying, yes, there are countless variations of dogs in the world, but that doesn't mean we should stop studying canine genetics.
Right.
There are still patterns and principles to be discovered within that diversity. So, with all these different theories pointing toward a multiverse, is there any way we could ever actually test these ideas? Could we observe another universe?
That's the million-dollar question. And it's something that physicists are actively exploring. Some argue that the multiverse is inherently untestable and sits firmly in the realm of philosophy. But others believe we might find indirect evidence for other universes by looking for subtle imprints on our own universe.
Like what kind of imprints? Would we be looking for cosmic bruises from bumping into a neighboring brain?
Something like that. We might search for patterns in the cosmic microwave background radiation, the faint afterglow of the Big Bang. Some think those patterns could hold clues about interactions with other universes in the distant past.
That's incredibly exciting. So while we might not be packing our bags for a trip to a parallel universe anytime soon, there could be ways to gather evidence that they're out there.
Exactly. It's a rapidly developing field, and new ideas and observational techniques are emerging all the time.
Yeah.
Who knows what the future holds?
Okay, so we've got the repeating universes, inflationary bubbles, brain worlds, and the mind-boggling string landscape.
Right.
My brain is starting to feel like it's in a superposition of states, simultaneously overwhelmed and exhilarated. But I know there's one more mind-bending theory we need to discuss. The many worlds interpretation of quantum mechanics.
Ah, yes. The many worlds interpretation. This one takes the idea of parallel universes to a whole new level. It suggests that every quantum measurement, every decision, every possible outcome creates a new universe.
So you're saying there's a universe out there where I had cereal for breakfast instead of toast.
Yeah.
And another one where I wore that purple shirt instead of the blue one.
Precisely. It's based on the idea that all possibilities exist. And with every quantum event, the universe splits into multiple branches, each representing a different outcome.
So instead of one reality, there's a constantly branching tree of realities with new branches forming every second based on every quantum event. It's like a cosmic choose-your-own-adventure book with infinite possibilities.
That's a great analogy. It's a truly dizzying concept. But to understand why physicists take this interpretation seriously, we need to talk about something called the measurement problem in quantum mechanics.
Okay, I'm ready for my brain to be bent a little further.
Okay.
What's the measurement problem?
Well, quantum mechanics describes the behavior of matter at the atomic and subatomic levels, and it's incredibly successful in predicting how particles behave.
Right.
But there's a strange thing that happens when we try to measure a quantum property.
What do you mean by measure a quantum property? Can you give me an example?
Imagine you're trying to pinpoint the location of an electron.
Okay.
Before you measure its position, quantum mechanics says it exists in a superposition of states.
Okay.
Meaning it's sort of spread out, existing in multiple places at once,
right,
like a fuzzy cloud of possibilities. But when you actually take a measurement to determine its location, the electron suddenly snaps into a definite location.
Okay.
The wave function, which describes the electron's probability of being in different places, collapses.
Okay, so we have this fuzzy cloud of possibilities, but the act of measuring forces it to condense into a single point.
Right.
What's the problem with that?
The problem is that no one really understands how this collapse of the wave function happens.
Okay.
Quantum mechanics doesn't provide a mechanism for it. It's just something that seems to happen when we make a measurement.
So it's like quantum mechanics says, poof, the electron is now here.
Sure.
But it doesn't explain how it got there.
Right.
Or why that specific location was chosen.
Exactly. And this is where the many worlds interpretation steps in.
Okay.
It suggests that the wave function doesn't actually collapse at all.
Okay.
Instead, every possible outcome of a measurement really happens. But each outcome occurs in a separate parallel universe.
So instead of that cloud shrinking to a single point, it splits into multiple smaller clouds, each representing a different universe where the electron ended up in a different place.
That's a good way to visualize it.
Yeah.
In the many worlds view, there's no mystery about wave function collapse.
Yeah.
It's just that all possibilities are realized, with each possibility creating a new branch of reality.
Wow. That is wild. But if all these universes are branching off all the time, wouldn't that mean there are an infinite number of universes being created every second? How could we even begin to comprehend something like that?
It's certainly a challenge to wrap our minds around such a concept.
Yeah.
The many worlds interpretation suggests that reality is a vast, ever-branching tree of possibilities, with new branches sprouting with every quantum event.
Okay, I'm officially mind blown. We've gone from infinite repeating universes to bubble universes to brain worlds to this idea that reality is constantly splitting into infinite possibilities. Where do we even go from here? Is there anything even more mind-boggling than the many worlds interpretation?
Believe it or not, there is. And it's called the ultimate multiverse.
The ultimate multiverse. Okay, you've definitely piqued my curiosity. Let's hear about this ultimate multiverse. The ultimate multiverse. It sounds like we're about to step into the realm of the truly bizarre.
It might get a little strange.
Yeah, what exactly does it entail?
Well, the ultimate multiverse takes the idea of everything exists to its most extreme conclusion.
Okay.
It proposes that every logically possible universe actually exists. It goes beyond just variations in physical laws and constants. We're talking about every conceivable reality, no matter how strange or paradoxical it might seem to us.
So there's a universe out there where gravity repels instead of attracts.
Yeah, it's possible.
Or a universe where time flows backward.
Sure.
Or one where the laws of physics are determined by cosmic game of rock, paper, scissors.
Exactly. If a universe can be conceived of without logical contradictions, then according to the ultimate multiverse, it exists.
Okay, now my head is really spinning. That's a level of existence that's hard to even fathom.
Yeah, it's a lot.
But if we're talking about every conceivable reality, wouldn't that include universes that are completely incomprehensible to us?
It could.
Like universes with dimensions we can't even imagine, or with forms of matter and energy that are beyond our understanding.
That's entirely possible. The ultimate multiverse throws out the rule book on what's possible. It encompasses realms that are so foreign to our experience that we might not even be able to recognize them as universes.
So it's not just about different versions of ourselves living slightly different lives.
Right.
It's about the existence of realities that are so fundamentally different from our own that they defy our current understanding of physics, logic, and maybe even mathematics.
That's the mind-boggling implication of the ultimate multiverse.
Okay.
It suggests that the reality we experience is just a tiny sliver of an unimaginably vast and diverse tapestry of existence.
It makes you wonder about the nature of knowledge and understanding. If there are universes out there that operate on principles we can't even comprehend, does that mean there are limits to what we as humans can ever know?
It's a profound question, and it gets to the heart of what it means to be a sentient being trying to make sense of the universe. Some philosophers argue that if the ultimate multiverse is true, then there are inherent limits to our understanding. There will always be realms of existence that are simply beyond our grasp.
It's a humbling thought, but also a bit daunting. But then again, maybe there are also universes out there where beings have evolved to perceive and understand realities that are completely beyond our comprehension.
Right.
Maybe somewhere out there, there are beings who can grasp the intricacies of the ultimate multiverse in a way that we can only dream of.
That's a fascinating thought. And it brings up another intriguing question.
Okay.
If there truly is an infinite diversity of universes, what does that say about our own place in the grand scheme of things?
Yeah.
Are we just a random blip in an endless sea of possibilities? Or do our lives, our experiences, our choices hold some kind of significance in the face of such vastness?
It's enough to give you an existential crisis.
Yeah.
But maybe that's part of the beauty of it all. The multiverse, in all its mind-boggling complexity, reminds us of how much we still don't know.
Right.
It pushes us to keep exploring, keep questioning, keep searching for deeper meaning and understanding.
I agree. While some might find the idea of the multiverse unsettling, I think it's also incredibly liberating.
Yeah.
It frees us from the limitations of our own narrow perspective and opens up a universe, or rather a multiverse of possibilities.
It's a reminder that reality is far stranger and more wondrous than we could ever have imagined.
Definitely.
And even if we never fully grasp the true nature of the multiverse, the very act of contemplating its existence expands our minds and deepens our appreciation for the mystery and beauty of the cosmos.
Well said. And remember, even though these multiverse theories are still largely speculative, they're based on some of the most rigorous and cutting-edge ideas in physics. Who knows what new discoveries and insights await us as we continue to probe the fundamental nature of reality?
Exactly. It's a journey that's just beginning, and it's one that's filled with wonder, excitement, and a healthy dose of mind-bending possibilities.
Yeah.
So to our listener out there, keep exploring the hidden realities of the cosmos.
Yeah.
And who knows, maybe you'll be the one to make the next groundbreaking discovery that sheds light on the mysteries of the multiverse.
Until next time, keep questioning, keep imagining, and keep diving deep into the mysteries of the universe.